Good afternoon. We are here at NBIRT. I am Richard Ghosh with my team. You can see my team is there. Also show your face. Okay. So here we are conducting a very important experiment. So first I would switch off so that you can hear me. So this experiment is very important because now today we are experimenting with a very small solar pumping system. So here is our main solar pump, which is basically a diaphragm pump. So as you can see, this is a diaphragm pump. It is a 36 watt pump, and the operating voltage of this pump is 12 volts, and it consumes or draws about 3 amperes of current at maximum or at peak. So it's rated at 36 watts. So our objective today is to run this pump entirely with our solar panels. We have a 125 watt solar panel above. We have connected this currently with 125, and we'll connect it with the 80 watt panel and see what are the efficiencies, what are the performance of this solar pumping system. So currently this is connected to a 125 watt peak solar panel, and now we are going to turn it on. This is the connector. This is, you can see the input, the output of the solar panel. It's connected to an MCB, and from this MCB we have connected this MCB to this solar pump. And let me walk you over with the rest of the setup. So from this bucket we are pumping water to the upper storage tank. We have a 300 liter storage tank above, so we are pumping water there through this pipe. So this is the pipe, as you can see, and it is connected 10 meters above. So head, this small pump will be pumping water at 10 meters head. This, you can see, 36 watt pump will be pumping water from at 10 meters head. So it's a very big head and power is very less. So let's see if it works or not. So we'll be drawing water from this bucket. We have a 5 liters bucket here, and this is an input from another tank, so that the water does not draw down much. So we will be supplementing water into this small bucket, and now we'll be turning the pump on. Let's see. As you can see, the pump is beginning to draw water from here. The level is decreasing. So now we'll be supplementing it with additional water, so that we need to supplement it because to maintain a certain level of water, so that water does not depreciate or does not go down much. We will balance the suction of water with some additional supplementing water from this water tap. So here we have adjusted this, so now it's balanced. Now let's see the power characteristics of this pump. As you can see, it's drawing about 18 volts, 17.75, about 18 volts, yes. And let's see the current consumption. Let's see how much current it draws. So it's drawing about 1.8 amperes of current. So if you want to determine that what is the rate of flow, or what is the pumping flow rate, what amount of water is it able to pump, you can see the head is getting reduced, so we need to supplement more water. So it's sucking up more water than it's getting delivered. This is the actual 1.57, 1.6 amps. So let's multiply and get the power. So we'll turn off the pump once, and we'll check the power. So it was drawing 1.6 amps, and we had 18 volts, so it's drawing about 30 watts. So it's a 36 watt rated pump, so it's drawing about 28 watts, about 30 watts. So it's a very good pump. Pumping is also good. So we'll go above and check what is the water delivery of the pump. So let's see, it's a very good experiment, and the major significance of this project is this small pump when fitted with a solar panel. So it can provide water in rural areas. So you don't have to buy pump with large capacities, 36 watt pump will do, and it will deliver easily about 1000 liters of water in an entire day, so which is very important and which is a very big amount. So for rural households, 1000 liter water goes for the entire day. You can use it for the entire day. So this project will be very viable in remote rural areas of our country, this India. So let's see the water delivery. You can see above. So we can conclude this. Here we are seeing the delivery pipe from the pump which is coming to the tank. So this is a 300 liter HDPE tank that we are filling with water. This is, you can see the water is flowing into the tank. So the water flow is quite admirable considering the size and the capacity of the pump. So this, you can see the water is filling, and as per our calculations and testing, we have observed that the flow rate is about 50 milliliters per second, and in a day, if you drive it through a solar panel, so in a day it can fill about 700 liters of water. So this we are testing currently. We are testing the flow rate of the water. So the exact flow rate, as we have shown earlier, that we have balanced this flow using the water which is coming from the tank so that the water level remains constant. So this, you can see we have filled 1 liter, and we have derived the flow rate from this. So this pump will be of great use in the rural areas, as it can be powered easily, very easily, from solar panel. We recommend a minimum panel capacity of about 75 watts. If you can find 80 watts, that's also fine. Below that, a pump will not work as expected, but if you buy an 80 watt peak solar panel and connect it with this pump, so the system will work optimally. It can give you about 700 liters of water. So if you have a 500 liter tank, it can be filled very easily through this process. Thank you, and we'll see you in the next video.